Okay. Eventually, hopefully, it won't be a black screen.
What's happening?
Nothing. It just takes a while to start.
I put in your account. Last one.
What about the Microsoft stuff? Do I need to do the same thing?
Just let me know after you register.
I'm registered. I already registered.
Okay, I'll take care of that.
All right. We are seconds from starting. I'm pretty close. So if you need a quick dash of your company. Thank you for your patience today, as always. So we'll do just a few quick things here to get you started on this. We got about an hour left. I'll try to take like a half hour, 45 minutes, if you want to work on stuff. Hopefully SQL Server will open here in a second. Why is it so slow?
Hatefulness.
It could be. I don't think machines resent us yet. They may get that.
Most of them don't.
Yeah.
You know the ones that are going on inside those processes.
Okay. So I'm going to use Community Assist. And we'll do subqueries. We'll just comment. Okay. So first I'll do the subquery that I was doing on the whiteboard. Basically, I will just select, let's do person last name, allocation, so grant allocation. And then there'll be a join here. So from person P, inner join service grant. So it gives you another join example. And I'll do that as SG. On P.person key equals SG.person key. Why is it not like SG? Oh, it does. It just takes it a while. Where grant allocation equals, and this, when you do a subquery, they're always in parentheses. All right, so select select max grant allocation. And I'm going to break this line just so that it's from service grant. Okay, so that'll give us just the person that has, and actually there, oh, where's the from? Why do I have an inner join? Oh, I left out a paren. So two people have the maximum grants, $1,200. Notice they're identical. So it shows their last names, Kim and Denny, have $1,200. That's the max grant that was out there. Does that make sense? So we're just, whatever grant allocation matches the maximum. We could do the same thing if we wanted the minimum grant. So I'm going to just change that to min, and it will be exactly the same, except we might have, so these are the people that got nothing. There are three people that got nothing. So I'm going to show you a couple of others. I'm trying to think of what the, any questions on that? Does that make sense? You guys okay with that? So, all right. I'm going to do a little bit different. I'm going to select person, last name.
So I just want to confirm the only way to get these results is with the subquery.
The only way to do it, I mean, there are some ways that you could do, like you said, you could, the only other way I can think of is you could order it descending for the max and then pull out the top one or two.
You would see the result, but you wouldn't get that specific.
Yeah, you wouldn't get that specific. And also, if you wouldn't know, for instance, you might not know that there were three people that had that minimum amount. So it'd be hard to know how many to extract.
Yeah.
So the subquery is basically the only way to do this. I'm going to show you a couple other uses of subqueries, and I'll show you actually a couple that are kind of complex but are also really require subqueries. Yeah.
So this begs another question, which is, if we have multiple queries that can give us the same, is there something that tells us, hey, this is, more efficient than the other way that you did it?
There is a thing. I don't want to necessarily go there, but I'll show it real quickly. So up, and it's where you can't see it, so I'm going to bring this down. There is a thing that says display estimated execution, and then there's include actual execution plan. I'm going to click on that, and I'm going to include the statistics. And I'm going to run that query again.
So you just selected those, you just clicked those?
I just selected those. And then what you have here is this will show you what kinds of loops happened. It'll show you what indexes were used. It'll show you all sorts of information. And there's even more information than it looks like, because if you mouse over, it gives you a whole bunch of stats about each of those nodes. So the gist of this is that you could look at the times and the percentages on all of those, and it's used to optimize queries. The percent cost is this, what percent of the total was taken by this particular piece of that, right? And there's also the client statistics. So there's a bunch of things that happened in that query, and then what the average time was in milliseconds.
So
Except for that's bytes.
Considering also the network traffic. So.
It could, which actually becomes really important when you're analyzing. Couple of things, though, we're not going to do this. We're not going to spend time optimizing these because that's a bit higher skill. But SQL Server has built-in optimization software. I mean, it's built into its engine to optimize queries. It will ignore what you wrote if it thinks that there's a better way to do it. It'll get you the same results, but if it decides that a join is better than a subquery, it'll set it up that way. And in general, it's hard to beat SQL Server's optimization. Right? It usually gets it right. It usually gets the fastest route. And if it doesn't, it usually will give you suggestions. And again, we're not going there, but it'll suggest where you need to build indexes. We haven't talked about indexes, but indexes are basically, standard indexes are just tree structures. So you start off here and then you go, and there'll be like 3 nodes here, and each of those will break off into a couple of nodes. And basically what happens is, at this point it'll decide which of these 3 nodes is the most relevant. So say it goes over here, then it'll decide which node is here and then here. And the thing is, it can go to what records you want if it's indexed. It's say 3 hops instead of having to go through 100,000 rows to find records. So the index indexes, and you can build. There are some places that make fairly awesome. It's usually things that you query a lot. Indexes are really good for speeding up searches, but they're really bad if it's a table that you have to update and delete, and if you're doing a lot of maintenance on, because every time you make changes in the table, it has to rebuild the index. And the index is actually a physical structure in the file. So. So if it has to rebuild the index every time, it actually can slow things down. But if it's something that you search a lot that doesn't change a lot, these indexes can really speed up searches. That's all.
Yeah, that's the database.
Yeah.
Data structures class. Right?
Yeah. But it is relevant. It's just not. Anyway, what I was going to do for the subquery, I was going to find a. So you could do this one with a join. It would help if I typed right. And I'll add employee hire
You
date.
still misspelled it.
I did. It's Fist's name now. I'm not going to. So what I want to do is say which people. What are the names of the employees? And again, a join would work here, and a join might even be better. But I want to show you how to do it with a subquery. So I'm going to say from person, and I'm going to say where person key. Why can't I type? Is in instead of equal. We haven't used the in operator, have we? And then I'm going to do a subquery. Select person key from employee. And if I do that, I get the names of all the employees. So what in does is in says that it has to be somewhere in the set of employees that are returned, the person keys. It's really important that the thing that you're looking for is the same as what is in the subquery. Does that make sense? If I said person key and then I looked for employee keys, they wouldn't match up. Right? You actually would get information back, but they would be wrong. The thing that you're searching for in the subset has to be, be the same kind of thing that you're asking for. Does that make sense? I mean, again, a join would do this just fine. But sometimes, if you wanted to do a query. And you can chain these. So I'm going to copy this. And it'll be a little bit weird, but so I'm going to, let's get a space between them. Let's say we want the first name, last name of the employees that reviewed service grants. So I could say where employee key, because that's the key that's relevant for the service grants, in, and then we could start another select employee key from, and I'll just pop this down so it's okay, from service grant. Okay, so I think 6 employees is all I have. And one of the things that can help a lot actually is if you, kind of indent these in a way that shows their relationship. I need 2 parens at the end to close the 2. So we have two subqueries there. And again, a join would do this just fine and maybe make more sense doing it. But
Returns the same data.
what?
The returns the same data.
Yeah, that's because there's no employees that aren't in the service grant. But if there were, it would only return those that are in the service grant. We could do it with person keys that are in which people are in the people that ask for the grants. Does that make sense though, as a structure, that kind of chain? And it's a lot like a join in that you're following the links, right? Person key to person key, employee key to employee key. And you can chain them together until you go insane, actually. You just keep adding them. One of the things that's difficult about this, though, and why a join is often better, is up here I can't ask for like the employee hire date or anything like that. I'd have to do a join. Now you can combine joins and subqueries, of course, but it gets that. But those make sense. The in operator looks for a set. When you have up above where you have the equal, then it has to return a single value. Right. If there's any chance that this doesn't return a single value, then this subquery will throw an error. That's with the equal sign. With the in, it returns a whole set of values. Okay, I'm going to do a really weird one, but useful one. So let's say, and I think maybe I want to write this out as a comment first. Let's say you wanted to know the total and count of each service, of the grants for each service, right? And actually, the other thing we want to know is the percent, the grand total. Let's just add grand total granted can't write, and the percent. Okay, so this is a big kind of summary thing for like the thing. So we want to see the grand total, all the money that was counted, but we also want to see the amount for each service, and we want to, and that's from each service, or for, and we also want to see the percent. Now you could do multiple queries for this, right? You could do multiple queries and get all this information, but let's see if we can do it in one query. And there's a part of this, at least, that's only doable with a subquery in part of it. And I'll show you. We'll do it in stages. First of all, let's get the grand total. Well, so the grand total and the total, how do you get those two together, right? The total per service. So I'm going to do select, and I'm going to do service name. So I'm going to have a join in here. Select service name, and I'm going to say sum grant allocation. And this will be, because of this is not a aggregate, this will have to be the total per service. It'll be grouped by. And then I'm going to do basically a subquery here in the select. So I'm going to say select sum grant allocation from service grant and I'm going to alias that as grand total. And then I'm going to say, for right now, I'll just say from service grant, inner join, so let's do SJ. Inner join, because we got person, our service, community service. On SG dot service key equals CS dot service key. That should be good. Oh, I have a comma where I don't need it. So I'm going to run that little part. Community service name. Oh, I didn't group by. Sorry.
If you alias service grant in the main query, do you have to use the alias in the subquery?
No, I don't think so. Because actually the subquery is independent. I mean, it's totally independent of the other query in a way. So when I run it, notice that it gives me, for each of the services, it gives me the total, and then they're all compared to the grand total, right? So if we want to do the percent, that's really what we need. The percent is going to be this number divided by this number. Is that right? So we've got the service name, the total. The only way we can get the grand total and the total together is with the subquery. Does that make sense so far? So if I want to do the percent, actually I'll build it in pieces, so I'll just copy it down. That way in the blog you can have the pieces. I'm going to do a comma after grand total. I'm going to do sum. Boy, I'm having trouble typing. Grant allocation. I'm going to put that. Oh, what did I do? The only way to do it, because otherwise you can't get that whole total in there. And again, this is complicated. This is starting to get complicated. It gets a little bit more complicated when I do, so I'm going to put a parentheses around the whole equation times 100. And if we wanted to do the percent sign, see if I can remember its format, another paren, And then at the end of this paren, or after the 100, I'd do the format, which would be 1, 2, 3 dot. Do we want 2 decimals? And then a percent sign. Let's see what happens if we do that. Is that happy? It's not happy with my
Need a
form.
comma.
I need a comma. I need a comma. Does this go in quotes? What?
Yeah.
Is it happy now? Doesn't seem to be happy, but let's see. Format function requires 3 arguments. What is the other argument? 2 to 3 arguments. I've got 1 argument.
Yeah, 2.
Yeah, 2 should be enough. What are the 3 let's see what I got here. Parameter. It might be a paren problem, yes.
We should only have one after the last service grant before the next.
Well, that was because I was doing this. Although I guess it doesn't matter because the order of operations would carry it anyway. But it still doesn't like. What? So we have some grant allocation, some times 100. Oh,
There we go.
yay. Whoa. Why is it 100 over?
Huh. Maybe the percent format does it automatically.
Yeah, I wonder. That is weird. I did not know putting a percent sign in the format would automatically multiply it by 100. But so what we have a report here that gives us the what percent. So 2% of the people asked for, for clothes, 7 for dental, 16 for education, 9 for travel. Each one of those. I do not know if that's adds up to 100. There's probably a way we could probably do a subquery to figure that out too. But. So that's fairly complicated. But it gives you, it's still only a few lines, and it gives you a pretty nice little report, of where each of these services are in the total. And you could break this up if you wanted by month and year. Okay. Let's see if I can think of a correlated subquery. That works on this one. You could also add like the count in here if you wanted. That might actually be useful. But I'm trying to think of a correlated subquery. It would, to add a count, you would just do count. And you could do averages. You could do anything you wanted. So correlated subquery. I'm just thinking if there's anything in this database that would make sense as a correlated subquery.
So now you got the service name, the number of grants, the total of the grants they have.
Right.
The total of the total grants.
Yeah,
Could
and
you
then
find the largest grant for each one of those? So like for childcare, could you also find the largest grant of the 10 childcare?
sure. Now, if you did that, that would take another subquery. So before the grand total, maybe. All right, so if I do that, oh, actually I did it in the wrong place. So there's the biggest, and again, it repeats. There's no way to not have it repeat, which is a problem.
Oh, so that biggest is any?
That's the biggest of all of them together. It's not the biggest per. Now that might make a correlated subquery there. That might actually give me that.
The problem you're trying to solve.
Yeah.
So we'd want the biggest for each one of those.
Right, and so
Service
to
names.
do that, so let's say if we just wanted the max per, so you could group by, right? I mean, just a simple query. You could just do select service name, grant allocation, don't even need to group really, but we could do from community service CS inner join service grant SG on CS dot service key equals SG dot service key. Okay, and then group by or not group by grant allocation or service name. My brain is gone. That actually would give you that query right there would give you the largest per thing. It's a different query. If you wanted to put this up in the other query, then you'd have to do a correlated subquery. But a correlated subquery in the middle of the other query, I think, would be way too complicated for right now.
Yeah, this verifies that 1,200 was the largest.
Right, and that was for education and all the rest, yeah,
Education.
and rent.
So this query would be one of the results at the top. And line it up.
Well, so that's what I'm saying. You probably wouldn't want to do that because it would actually not allow you to do that.
Why is that?
Because in the select clause, every query has to return a single value. This returns a table of values. I think I could make it work, but I also think that I would lose you all. Because it would have to be a correlated subquery, but to do it in the middle of all of this, because to make it a correlated subquery, so it would have to be the outer query. But this is already a horrendous, but it is. I'm just trying to think of average. I guess to select service name. Let's do this one.
So a correlated subquery is a subquery that uses results from the main query.
Right.
So is it mainly used for like formatting?
No, basically it's used for like when you have unequal values and you want to make sure that like is compared to like. So what I'm going to do is I'm going to go
Can
to
you
my,
give us a simple example?
what?
Can you give us?
Well, that's my problem, is coming up with a good example. I don't know that I have a good, anything in the community assist. This works, but it's a different database. Let's see if I can find a better one. I don't know if I ever used one. Do I have anywhere, I wonder if I have that magazine database anywhere that you can download the script real quickly. Because I used magazine subscription for years for this. I'm going to copy this so I can at least talk through it. I might actually be able to get the database too. So this is all red because I don't have the database right now. Different magazines have different subscription types, so that like you could subscribe for a year, or you could subscribe for 6 months, or you could subscribe for 5 years. So to compare the average prices of those doesn't make any sense, you know, to compare them equally. So you want to compare them by kind. So what makes this a correlated subquery is that this compares the average price from up here where the subscription type ID is equal to the subscription type up here. Let me try this. I think I can do this with, let's do it with, say, which services, which grants are greater than the average for that service? Because that's essentially what this is doing.
Say that again, which grant?
So when we do this, like, right, so if we do a quick select average, let's do select service name, or just, let's do service key just to be fast. Average grant allocation. Okay, and then we'll do from service grant. And then basically we'll group by service key. All right. So each one of these is going to have a different average, right? These are the average grants for each service. I didn't get the service name, but I got the average grants for each service. So if we wanted to know in the service grants, how many grants, we want to see the ones that are bigger than the average. Does that make sense? But we need to see the ones that are bigger than the average. It doesn't make sense to compare apples to oranges. We want to compare this to, I mean, food to food and clothes to clothes. Does that make sense? To see what the biggest services are there. So I think I can make a correlated subquery out of that. Maybe we do want service name. But we'll do this down here. So I'll leave it as key here. Let's go down. I am going to select, and what we want is the service name and grant allocation. And we'll have to do a join, which is a bit of a problem. I mean, it'll make it a little more complicated, but from community service, well, actually, let's just use the service key. I don't want to make it complicated. It makes more sense with the name, but so from grant, service grant, and I'm going to name this as SG1, service grant 1, or Stargate 1, whatever you want. I missed that show. Anyway, then I am going to do a subquery. Well, actually, I'm going to say where. I'm looking up here. Where grant allocation is greater than, and then what we'll do is a subquery. Select average grant allocation from grant allocation, and I'm going to break that line just for readability, SG2. All right, so it's the same table, but it's aliased differently.
From grant allocation or from service grant?
Oh, service grant, sorry. Brain is gone.
And we're going to call that a different.
But SG2 is still the, where SG1 dot service key is equal to SG2 dot service key. So this is a correlated subquery because this query has to refer up here. And what it's going to do is it's going to keep it from comparing apples and oranges. It is only going to look it's only going to compare service key 1 to the average for service key 1. It's only going to compare service key 2 to the average for service key 2. It's not going to compare them to the general average, right? So you're not comparing apples and oranges. I'll try to do a join here in a minute, but join would complicate this because you'd have to have a join in the subquery too. So if I run that, it gives me all the ones. See, like there's 2 for service key 1 that are bigger than the average. Do you remember what the average was? I should run that one again. It shows there's 3 in number 2 that are bigger than the average. There's several 3s that are bigger than the average. You know, it shows me all the grants that are bigger than the average grant. And again, if we just do so if I just select the average grant. So the average is 281. So all of those that we are shown for 1 are bigger than 281. Actually, that isn't 200. What was it?
It's by service key. The average by service.
Let me try it again. So I want to look at it is by service key. That's the grant allocation for 1. I want the average grant allocation. 281. So why am I getting 1?
I looked at both of them, starting at 58. and
Yeah.
showed
It should be where the service keys are equal. It should be getting the average grant allocation from the second table where the first service key is equal to the second, but 200 isn't correct.
the average for service key 1 is 128, so that's like
What? The average is 128?
for service key 1.
So then that would be correct.
Yeah.
So why am I getting something wrong here? Oh, because that's not doing the grant allocation. Never mind.
Is the parentheses in the wrong place?
No, I think it's actually working okay. Because if I do, what is the average? Okay, so let's just do a quick select average grant allocation from service key. My brain is not functioning. I think it's actually working fine from service grant, where service key equals 1, and it's $128. So both of those were above the average, right? And if I do 2, the average is 658. So if I do this again, so 2, they're both above. All the 3 of them are above 658. The ones are above 128. I was just spacing wrong. It works. It's a correlated subquery where it's comparing like to like. It's not comparing it against the generic average. And that's basically where you would do a correlated subquery. And what makes it correlated again is that right in this where clause, the inner query is querying the outer query. Correlated subqueries, like recursive functions, are extremely inefficient of processor time. So
Yeah,
avoid
the
them when
second
you
query
can.
has to check every result from the first
Right,
query,
so
right?
it has to check everything like that. So we basically what we're saying is we want the average where it matches the service key. So for every single row that it returns, this one has to check every single row by row, to get the average. So our data thing here, I think that at the most there's like 150 records. But imagine if you had several million records and it had to match row by row. It could take a while. You know. So they always tell you if there's any way to do it without recursion, without this coordinated subquery, do. On the other hand, I have read many times at the whiteboard that they're going to, you know, if you go to a job where you're going to be working on a database and writing SQL, they almost invariably ask you to write a coordinated subquery. Because it's something you don't use very often and they're difficult. They take a bit of logic. And again, it gets worse if I were to do a join, because I'd have to, the setup here has to equal the set down here. That's why I did the number. I just wanted to keep it simple, just to show a correlation. Even though my instincts wanted to see what the numbers mean there. I think that's good for subqueries. Let me see if there's any. I'm not sure. I haven't looked at the assignment this morning. So is there any piece of subquery that I totally left out? The chapter, if you ever look at it, does talk about exists, though I don't use it much in there. It talks about some of the troubles you can have with subqueries. They can not always return what you think you're returning. All right, no questions? You guys are so quiet. All right, I will post this on the blog. If there are other things, we can certainly deal with them on Tuesday. You could email me too if you really feel desperate during the weekend or something. I do get desperate emails on the weekend. Not from this class so far, that I know of. So it just seems like the subqueries, there are other things I should cover with them, but I think that's the gist of them. Going to get rid of this since I actually made one. We'll see ya.